Excellent, it works. Okay, let's get started. My name is Dmitri Levin. I work for Alpha Broader in Pennsylvania. I prepared this presentation together with George Potomkin from the unknown country, unnamed country. And he made a lot of stuff going into this presentation. This slide I will explain a little bit later. So first I want to tell that we took a lot of from the GAS monograph that was published almost 30 years ago. And that is where you can look this through. And first of all, oops, I forget which one is next. Okay, next. Okay, this is the block, how it looked in version 8 when it was SAT1, sorry. And when I show you how it looks today, it has a lot of similarities. A lot of fields are similar. Oops, sorry, I just need to find. So the next, this is how it looks for SAT2. And I will split this slide into two to make it a little bit easier to look at the details. So that is the header of the block. So it's basically the same, just the top part of the slide. So it has the block address, the type of the block, which I'll talk a little bit later, the chain number, the counter, incremental counter. This is related to the backup. Like, when the backup runs, it should know whether the block was changed or not changed, and it looks right in this field. And it has also a bunch of new fields added, which we didn't have at SAT1. All the new fields are 8 bytes long, so the line represents 8 bytes. If it is half, then it is 4 bytes. If it is a quarter, like this one, it's 2 bytes, and the little ones are just 1 byte fields. And this field is basically extension to that field. And DB key is basically a pointer to the storage object block. So it basically tells to which table this block belongs. So this information you can get either from object _ storage object VST or also from every block. And I will show the object block a little bit later. Okay, and that is the bottom part of the same screen. It shows that some blocks that are the first block of the cluster or the last block, they have extended header. So instead of 64, you can see that it's 8 multiple 8, it's 64 bytes here. On the next slide, if it is the block is the first or the last, it will have extended header, which is 80 bytes. And then it has the same fields that you have seen on the GAS slide. They didn't change. This field represents the maximum slot that is used in that block. And this field represents how many slots are free. So usually some of them are equal to RPB, but it's not necessarily, because we can have like fifth slot is taken and the fourth is not taken, so this number could be a little bit bigger. And this number represents the size of the free space. So basically the records are kind of packed at the bottom of the block, and everything between the header and the records is a free space. And also there is such thing as a record offset directory, which I'll explain a little bit later on the next slides. These two fields will be important when we'll talk about RM chains, because it's important. The progress will check using the toss limit to make sure that this block belongs to RM chain using this field, and also if it has enough slots. Like if this is 0, that means the block have used all the slots and you couldn't put any more records into it, right? Okay, this is the types of the blocks that you can have. Basically, it's this field and then this field. So, oops, sorry, I'm still confused which one. Okay, so we will talk mostly about the data blocks, but a little bit we'll see also the object block and some. You can receive this list from DB repair. If you do DB repair, you can receive this list. And this is chain types. So the block could be on RM chain, on a free chain, or not on RM chain. That's only 3 choices. And when the first cluster, the first 4 blocks of the first cluster are those blocks. So when you create a new table, immediately the first 4 blocks are created, starting with the object block, which is the first one. And the object block will look something like that, which is also interesting. By the way, all these blocks we just did by doing DB repair. So we dumped the contents of the block, and that's how we see. All the labels that you have seen on the previous slide are also the labels that DB repair puts in. So this is an object block, and I highlighted here, bold by bold, the information that pertains for the chains. So obviously it's not on RM chain block because it's a special block, it couldn't be on any chain. And number 12, as you have seen on previous slide. Chain first is the DB key of the first block on RM chain, and the last is obviously the last chain on a block. Total blocks, it's basically total number of blocks that belong to this object, including the 4 that you have seen here. And the number of blocks on RM chain is basically how many blocks are currently on RM chain. In this case, you can see that since 8 is total and 4 are special blocks, all existing data blocks are on RM chain. And this field is high watermark. It's kind of a high watermark for this table, this object. So if this table is the only one in the area, it will correspond to the high watermark of the area. What is also interesting, if you look for if this table lives with other objects in the area, then the high watermark for this for the table that will be growing the most will correspond to the high watermark of the area most of the time. So that's how object looks. And that is a record of set directory. Remember, I said that I will tell us. A record of set directory is basically the offset of every record in this block, and it is 16-bit field. It has 3 bits special, which tells whether this record is fragmented. Like if it is 00, then it's one piece. It's not fragmented record. If it is either 1, 2, or 3 in binary, then it is a fragmented record. And 4 is something special, placeholder. And the other 13 correspond to the offset of the block, because 2 in the power of 13 is exactly 8K. And from this slide, you probably see that Progress is unlikely to make bigger block size than 8K. A question?
It's possible to make bigger block sizes, and then you make this a word offset instead of a byte offset.
Oh, okay. Good. And also the maximum of size of this record offset directory, in case you use RPB 2256, which Gus advised not to do, and I completely agree with that, don't make any tables in RPB, then it will take 510 maximum size of the record offset directory. Okay. Yes.
Offset directory is variable size.
Mm-hmm. It's
So
not.
if you have records per block 32, you don't necessarily have 32 in the directory because it grows until there's no more room in the block, or you hit the maximum. But it starts out small.
Okay, so for the for 256, that's a correct picture, right? If you, yeah. Well, you have to have for this, yeah. Okay, good. Okay, now let's see the record delete algorithm. The question for the audience, can the block become absolutely empty if you delete all the records?
In theory, yes.
It's still going to have row ID placeholders.
What's the block?
Correct answer. The answer is that there are placeholders. So if you delete the record, progress has to reserve the room, reserve the place for this record in case transaction will be rolled back. Because progress will immediately delete it, but it will put a transaction ID inside, in the place of this record. So if the record is rolled back, it will put it exactly at the same place, reserving row ID. However, this other space could be used. So progress reserve 8 bytes, but only 4 bytes are used for transaction ID. Why the progress reserve 8 bytes? Because it needs to have a pointer at least for the next block where it will put the rest of the record. So at least 8 bytes are reserved for the placeholder. Okay, and this is a little bit philosophical slide. Yes. It basically says that blocks on RM chain are not much different from the blocks that are not on RM chain. The only difference is that they kind of elevated. We consider that them partially full blocks, and we consider that we can put records into this block. And the blocks that are not on RM chain, we consider them full. And if this full block has some records deleted or updated, and it has more room, it will be immediately put on RM chain. And if the block is on RM chain and becomes full, it eventually will be removed. That's why we put it, this from the Bible. And that is a slide which is absolutely new. It tells that progress has actually 2 record creation algorithms, not one. And the divider is the variable that we call frag size limit. It's our name. It may be something different in progress. And it basically decides whether the progress will use small record creation or large record creation algorithm. And the frag size limit is block size minus 120. So that's that. If the record that you're going to place is smaller than this side, then it goes to the small record creation algorithm that is very good described in a monograph that Gus wrote. However, if the record is bigger, then starting with 10.1a, which is obviously way later than the monograph was written, it goes to the large record creation algorithm, which is completely different. And before I go forward, I need just remind that there are 2 things called create limit and toss limit. Just a reminder, create limit is the space that should be left in a block when you create a record for the records to grow. And toss limit is the divider between the blocks on RM chain and not on RM chain. So basically, the free space is more than toss limit, then it is allowed on RM chain. And here you can see the minimum and maximum values and for this and that, and obviously the default. And create and toss limit are per table. And also, as Gus said, toss limit should be bigger than create limit. If you make toss limit smaller than create limit, then bad things start to happen. Okay, so what happens is basically if we have a small record and we want to put it in a block, then the condition is that when we put it, it should at least have a create limit left. For the large record creation, create limit has absolutely no meaning. TOS limit does, but not the create limit. The only condition to use the block is if it is bigger than so-called frag-TOS limit, which is another constant that we created. I don't know how Progress calls it. So these are two conditions. But before Progress puts a record into the block, it needs to do some kind of cleaning. So the very first thing, it checks if the block has enough space using the TOS limit. Remember these two fields that I pointed at the beginning of the presentation in the block header? So it will check if the TOS, if the free space is bigger than the TOS limit, or at least the same, and it has enough slots. Because if there's no slots, then the block is going out of the RAM chain. But this if Progress evicts the block from RM chain, it couldn't do it indefinitely because time wasting, so it has a limit. And this limit, we called it cleaning depth. So basically, it will clean maximum of 100 blocks, it's a constant, from the RM chain before it's abandoned the process and takes a free block. So if the block is good, then Progress will try to consider to put this block on inside. But if the condition, if the record is bigger, meaning that these conditions do not match, either this or that, then Progress will move the block to the back of RM chain. And again, this process of moving blocks from front to back couldn't go unlimited because time, we need to put the record into the block. So there is a limit, and this limit is controlled by this startup parameter. You may have seen it in the startup of the database. Unfortunately, this startup parameter is one for the whole database, and all the tables are different. They have different behavior, and they have different RM chains. So I believe that this parameter should be like TOS limit and like create limit per table, not one per the database. And back in version 8, it used to be just 3. So 3 blocks are allowed to move from front to back. Okay, let's assume we have a block and we can put the record into the block. It's good. So in the first case, the record is just, if it is a small record creation, we just put the record and move on. But if it is a large record, then Progress will put a first fragment into this block, assuming that, and then it will also leave, it will take all the space on this block with exception of either 4 bytes. If this block was empty and didn't have any records before, then it will just leave 4 bytes. If this block had some records before, it will leave an extra 25 bytes for the neighbors. That's how we call it, just for growth of the neighbors. And then
add one thing to the previous slide.
That's all?
Yeah. Also, the dead placeholders get deleted.
Yes.
And so the free space is affected by that
Yes.
as well.
Absolutely. Yes, of course, when Progress check, every time it checks the block, if transaction already, if you remember I put transaction ID in a placeholder, if transaction already completed, then placeholder is deleted. Sure. Okay, so Progress will put the first fragment on this block, and then with the second part, the second fragment, it will go again back to the beginning. It will start the process all from the beginning, checking the next block, and so on. And usually, if you have a large record, if the first fragment goes from big record creation, very likely that the last one will go through the small record creation. Okay, and that table represents the fractose limit. Remember, it is a limit which decides whether the block is good for the large record creation or it is not, and it should be moved to the back of RM chain. And for the different block sizes, it is different for the 8K, which probably all of you have the database, I guess, 8K. That is the fractose limit, which is approximately like 70% of the block should be free in order to put a large fragment into it. Okay, what Progress does if it couldn't find blocks? So basically it will happen if it's either 100 blocks removed from the RM chain, or if we exhausted the moving blocks from front to back. Then Progress will take a block from free chain and put a record over there, and after every iteration like that, it decides what to do with the block. The block could be moved to the head of the tail, to the tail, the end of the tail, or it could be completely removed from the RM chain if it is filled in. But there is no mechanism to put blocks on a free chain in SAT2. So in SAT2, the high watermark will be raised and the whole cluster will be added to the front of RM chain, and here you have an empty block which you will use. So that's this algorithm. What happens if the record is updated? If the record is updated and the block is not on RM chain, for example, the becomes smaller, then the block could go to RM chain, obviously. But if the block is already on RM chain, it is updated, and it doesn't have any more space, then it will stay on RM chain, because the blocks other than the first are never removed from RM chain. The block should go all the way to the front, and then it will be evicted from the front of RM chain. And here are the space management algorithms that we know. Obviously, the RPB effects, which is a record per block, and this is obviously per area parameter, create and toss limits, which is per table, and this parameter, which is one for the database. But also there are a bunch of undocumented parameters. Some of them I mentioned already, like the cleaning depth of 100 blocks, and the ones that are here highlighted in black, they are related to the large record creation algorithm. And also there is a rule of 5 unused slots, which I will show on the next slide. And this rule basically governs where the block goes, to the head of RM chain or to the back of RM chain. If the block has 5 unused slots, then it will go to the head of RM chain, and if it doesn't have that many, then it will go to the end of RM chain. That is not very good block. Like if you use, for example, large objects and you set RPB 4, then you will never put any block on the front. All of them will go to the end.
That rule is a very old rule that's still there.
Yes, that rule could have been better.
Yes. Especially if you had 1K block size.
Oh, yeah. But hopefully nobody uses. I use 1K blocks for my testing, like in a sandbox, which is very good. But other than that, no. And that is activity monitoring that this is a screenshot basically from my database for 1 day. The act space is a table which has 1 record, so I probably should put here find instead of for each, but my ForGL is not very good. So it's just 1 record, and it shows you how many blocks goes to the front and how many blocks goes to the back, and you can see that almost 1,000 times more blocks going to the back of RM chains, because that's collectively for all RM chains, than to the front. And also how many removed and moved from front to back. So it's very good statistic. I believe it should be statistics per table. Then we can make much better decisions than one statistic. Maybe it was created in version 8 and never changed since then.
This VST.
Yeah.
Okay, that was my thought.
Okay, and the result of everything I said is this screen. This screen shows my table, which I call, let's say, called table number 1. This is how many blocks it has on RM chain. And this is how many blocks are going away from RM chain. So that many blocks left RM chain every week. How we did this, we ran chain analysis offline. And for this table, chain analysis will run for 7 days. For one table. Well, this table takes an area. You couldn't run chain analysis per table, but you can run it for the area. And it takes more than 7, it's like 7.5. So we ran 7 days, and we ran another 7 days. And we can see how blocks are moving along the RM chain. It's like a river. And you can kind of point, this block was here, now it is here. So in 1 week, we have that many blocks that are left. So if you do a simple calculation, you take all blocks that we have divided by how many removed from a week. We need 448 days for this block to go from back to the front, which is 12 years. So the moment I'm speaking to you, in my database, if the block goes on RM chain right now, it will be on the front somewhere in 2036. It's a big chain. If you do dump and load, right, that's a way to go. And since we're talking about Dbanalys and chain analysis, I just have to say a couple words about these two utilities. Dbanalys online and Dbanalys online are two different utilities, which probably most people don't know because they produce the same results. If you run Dbanalys offline for the database, probably you don't, and I don't do. It could run 10 times longer because it checks the chains. Similar to chain analysis, it does check the chains, but it doesn't report it. The report is exactly the same. So that's why I run Dbanalys only online, and obviously I run it on a target database. I don't run it on a primary database. And I do it every 5 days. Now, with also the option of scan exists in Dbanalys, but it doesn't do anything. The option scan on chain analysis is very useful because if you run chain analysis online and you don't use a scan option, the chain analysis will compete with the 4GL users, and they start fighting for the resources, which is not good. Obviously, so if you run online chain analysis, always use scan. However, in this option, Progress will not report the bad blocks. It basically will skip it. So unlike offline chain analysis, it will just pretend that they don't exist. So we use Dbanalys only online, and chain analysis we use offline. And now I have a couple of slides. Where's time? Oh, we're good with time. These slides represent a zoo. Well, I will show you why. And it's show about record distribution. So this is the same table number 1 that I showed you before. And you can see that most of the, okay, doesn't work. Most of the records are smaller sizes. However, we have records up to 7,000 bytes. Sorry, it's died. No, I mean, next slide. Oh, it works. Clicker dying. Okay. I will have to sit then. Okay, so I don't see the pointer. Okay, so that is, This is a full range of record sizes, but most of the records you can see are smaller bytes. Let's see at the same picture, but only see the tail. Thank you. Oh, great, thank you. So this represents the so-called snake tail, which basically, because it is kind of diminishing, you can see that all the records are diminishing. And I took this note from the Tom, know your data. So this represents basically the table and the record size that are diminishing. And we can safely ignore them because there are very few of them of big sizes. Now, this represents a different, this is a lob, table with a lob. And the lobs, they have a picture of record distribution very much like a dragon tail. Have you seen the cartoons when the tail of the dragon is like that? So the tail of the lobs are, at least in my database, they're always like that. They like have humps all over it. And that picture represents the same table number 1, but with record sizes smaller than 300 bytes. The average record size for this table is 231, so it's somewhere here. And you can see that almost, we don't have records which are the same size as the average record size. So our understanding that the record distribution, like a normal Gauss distribution, it not always work. For some tables, you can have that distribution, we can have 2 humps. And the average record size would be somewhere in the middle. Okay, this is kind of difficult slide. It shows the age of the block on RM chain. Well, if you look at the block on RM chain, there is no date on it. So how we calculated the age, we grouped the blocks by 10,000. So every dot here represents a group of 10,000, and then we took the maximum block ID, DB key, the maximum DB key of this group. And the maximum DB key of the group of 10,000 is often similar to the high watermark of the area at that time. So if you have Dbanalys, you know the high watermark of the area, and then you correspond the time of the block using this method. And for some in the middle, for some blocks in the middle, you can see that it's constantly growing. And for the other parts, it's like pretty much random. And here is why. This is the high watermark of the table number 1, the one that has almost 90 million blocks on RM chain. What happened is basically somewhere in 2019, which is over there, our programmer decided to put JSON object inside one of the fields. And JSON object is big field. And after like a couple months, I noticed that high watermark is behaving like that. And I asked, why do you do this? They say, we put it for debugging purposes. So I asked them not to do that and remove this, JSON file creation. And after that, obviously, the high watermark was flat. So on the previous slide, the slide where you can see the block age is correspond exactly to when our high watermark was growing. And that's why, that's basically was the period when RM chain grew to the size it is right now. And as you can see, the period of growing finished in 2021, which is like 3 years ago, but RM chain is still big. And it will take a long time for RM chain to become smaller. And this is another table from our zoo. You can see that the same method of using groups of 10,000 blocks, the age of the block, because the high watermark of this table constantly growing. You can see it, this line. That's why we have almost constantly growing of the age of the blocks. And this picture represents the use space. So we took the same RM chain from table number 1 and how much space is used in a block. And obviously the newer block that are recently put on RM chain, like right here, they are filled. And the blocks that are very, very old, which probably more than 10 years, they are not filled at all. Because we have a cleaning process, we don't keep records that long. 12 years. And this is another table, and you can see that RM chain exists, but it basically has almost all blocks are free. And this is the third table, which is order table, and it basically, you can see it goes a different picture. And finally, it's a fourth, this is a LOB. So with LOB, you can see that almost all blocks are filled to capacity. So even though they're on RM chain, we couldn't put anything in that blocks. Okay, and now let's look at the source of fragmentation. So example here is from the sports database, and this is a stable Dbanalys for that, and the simple code. You've probably seen this code many times. The question to the audience is why both create and update counters increase?
Is there a create
Period's in the wrong place.
Huh?
The period's in the wrong place. That's why.
No.
Is there a create trigger?
Yes. Well, you received 2 of them today. It's stress relief.
I need it.
Yes. It's create trigger. Create trigger. Basically, what happens as soon as you progress execute create, it would not create a table record. Sorry, it wouldn't create a record if not a create trigger, because this field is indexed. Remember, cast number is indexed field. So in order to create an index entry, it needs a row ID. In order to have a row ID, it needs to have a row. So progress creates a row, puts the customer number in that row, and put a row ID into the index. And so what it does, it takes a template, that's a template record for this customer table, and when it creates a record, it will be approximately like 50 bytes. And then it will execute a sign, which is different, even if it is a moment later, and the record will expand. So let's assume the block where this record goes has only 200 bytes left. So the record of 50 bytes will perfectly fit because it will put 50 bytes and 150 create limit. Create limit is 150, it will be still left. So it will put this record into the block, and then the blocks start expanding. And if this record is a big size, like 226, it needs another 176 bytes to increase. But there's only 150 left in the block. So we'll have fragmentation.
So would you recommend fill the character field with the minimum record size, so you space it out? In the create trigger, would you recommend to fill a character field with the space, like just blank, or just something, just to the size of the record?
I think the assign, it's basically the recommendation is on this slide. You can ask developers not to write updates after create. So somehow you need to make in one piece. So all values should be assigned at the same time.
Get rid of the create trigger.
Yes. Question.
Well, when the customer record is created from the template contains all the default values.
Yeah.
So if you put a big default value,
Yes. Yes, so the template is 48 bytes. If you change the template default values, if you create a big initial value for some, then it will fight. Yeah. You can create a character field, make a default value of something, and then it will be created. Yeah.
But then when you do the assign,
Yeah. So, but that basically the idea is the problem of fragmentation is creates updates after creates.
so there's another way to get the update after create. If you don't have a create trigger, then if you put all the fields in the assign statement, in one assign statement,
Yes.
then the record will be created with all that stuff.
Yes.
But if you put a period in the middle of the assign statement,
Uh,
then you will get assigned, the record will get created, and then you get update from
Yes.
the following statements.
Yes.
I've seen this in customers.
Yeah, the one period makes the difference. Okay, so what is fragmentation? I said fragmentation a couple of times. If you look in this is a picture of Dbanalys. The fragmentation is the difference between the record counts and the number of records, which you put here, and divided by the record count. So that is fragmentation. And why fragmentation is bad? Let's see it. So when a record is created with anything, when we read the records with anything other than the no log, log table is needed, meaning for exclusive logs, for shared log table is needed. But when you read the record with no log, then log table is not needed, correct? It's only if the record is not fragmented. If the record is fragmented, then we need to have a consistent read of all the fragments. And for that, you need a record get log, which is another entrance in the log table. So basically, it prevents any other user of modifying or deleting the data while you're still reading it. So,
If you're reading no log, you still get the record
yes, yes. If you read the records with no log, you're still locking it if the record is fragmented. And this is, of course, a very short period of time when the progress reads the fragmented record, and all the logs are removed as soon as the last fragment is read. Now, let's look at the difference between exclusive and shared log and record get logs, which, by the way, is also could be shared or exclusive. And I put a kind of wall between them because they are very different. Normal records are controlled by application, so you can control the scope of your transaction, and this way you can control how long exclusive log will be held. Unlike the low-level locking methods, they are not controlled by your application at all. The exclusive and shared log, they exist for much longer time, while these logs are very, very short-lived. And finally, these logs are not needed if the record is one piece. If the record is just one, you don't need these logs. And this is example from my database. We counted for several days. We counted how many record reads and how many record get logs we got. And we found that approximately more or less consistent 15% we read the records that are fragmented. However, the Dbanalys shows that this is for the whole database, that this is how many records I have, and this is how many fragmented. So on average, I have only 2% of the records are fragmented, not a lot. And also, we do not see fragmentation for the LOBs. That's not reported. And also on this slide, you can see the weights. The weights, which you can also see either under this VST or in Pramon activity screen log table. You can see this information. It's basically when exclusive record get logs, but we don't know. We don't know if these are for exclusive record get logs only or both shared and exclusive. This I don't know. But this is kind of collisions, and you can see that collisions are very, very few. If for the whole day we have only like single-digit almost collisions, so that's not important. So why my database likes to read fragmented records? Remember on the previous slide, it reads 15% of the fragmented records when we have two. Maybe the LOBs are contributed to this picture. No, LOBs don't contribute to this picture. The question, can we see which tables we read fragmented records? The answer is no, because table stat provides information how many records you read. It does not tell us anything about fragmentation. Also, you couldn't see which process create record get logs, because record get logs are not in any session statistics that you get from progress. So we want to find which tables needs fragmentation the most, but this answer we just couldn't get. And what happens when a record get log happen? So basically record get log involves two latches, two of this type and two of this, 4 total, and one record get request. And this is the latches that spelled out. Now we did the test with a read probe. So we created a table which is 11% fragmented, the number of records with this number of fragmented records, and read probe for this table runs that much. Well, when we run the same table without any fragmentation, we got 26% improvement. So obviously you can see that it reads faster if it's not fragmented. Okay, what happens when the record is fragmented and we create a record? When progress creates a record, it first creates a first fragment, and then it needs to put a next DB key for the next fragment. But it couldn't do it at the moment it creates a first fragment because the second doesn't exist yet. So it creates a first fragment, then it creates a second, then creates a third, and then it needs back and put the next DB keys in all of them. That's why blocks with fragments are always changed twice. Now, a different question. Is I plus equal I plus 1 is a costly operation? Obviously, if I is a variable, then it takes 50 microseconds, and this operation is very, very fast. But what if I is a record? If a non-index field. So if we update non-index field, there is only one change node, and this change node is 72 bytes. So relatively small. Obviously it takes much longer than 50 microseconds. Also, if it is a non-index field, you can see that act record is we have one update and one fragment. By the way, this is also, I believe, one record for the whole database. So it's not per table. And in record bytes updated, it will be the whole size of the record, whatever is the size of this record goes. Let's see what happens if the record is fragmented. For this test, we took a 1K block size database, and that's why 1K is helpful just for the test. And we created a table which has two fields, one integer and one character. And the character was almost the maximum, 31K. So we ended up with a rec which has 34 fragments of these records. We tried to make the most. And here are the results of reading this, updating this record. So if we compare the record that is not fragmented with a fragmented record, we can see that this has one node of this size. The node depends now of updates, of course, but big update or small update. And this is the changes that you can see in VST, in that VST, by the way. If the record is fragmented, in this case it is 34 fragmented, then the number of nodes increased. We can see 68 nodes. And 34 of this delete and 34 of create. So basically what is happening, we still can see a record update, but there is no fragment updates. Look at this 0. Instead, we can see in this case 34 record fragment deletes and 34 fragment creates. That means, thank you very much. So that's what's happening behind the scenes. We delete and create fragments. How to fight fragmentation? Well, first of all, as you say, do dump and load. Obviously it works. Second option, do pro-to-pro, because that's the same dump and load, but on steroids. Third, use Mike Furgal's dump and load using partitioning method.
It's really Patrice's, but thank you.
Oh, okay. Patrice method. And you can also use table reorg. I believe Gus made presentation about that. A bunker talk is about that, okay. But this is only starting 12.3, so like if it is me who is running on IBM AX, I couldn't go that far, even if I upgrade to version 12, which I should. The other method, you can increase the create limit or choose a smaller RPB. Well, if you choose a smaller RPB, you go back to dump and load. So that's not a method. With increased create limit, I tried to do, sometimes it does work and sometimes it does not. It depends how many updates your application does after create. If it's really aggressing into updates, then create limit might not help, but at least it alleviates a problem sometimes. So that's what you can do. Okay, so let's talk about how to configure these parameters. Records per block, rows per block usually has a recommendation something like that. So most people recommend use the mean record size and then subtract something from the 812, so 8K, you subtract some number and then you do something like that. Yes. And look at the picture. This picture you have seen already before. It's my table number 1, and it has 2 humps. And this is, oh, finally my thing working. So 231 is the average record size. So if we take this as average record size, 231, and we put in this formula, we can get 16K block size, right? But for this, the records that are in this big hump, the better one would be actually 32. And if we took this hump, for these blocks, actually the better would be 8K, 8 block.
If you set it to 32 and then don't think about it anymore,
Yes.
you'll be fine. Because then when you have the big records, you don't use the whole 32
Yes.
slots anyway.
Yes.
So.
And these days we have raw IDs enough.
Yes.
Well, there's exceptions to everything.
Oh, okay, yeah, of course.
Yeah, actually in this case, it's better not to use 16K, better to use 32, and the following slide will show you why. This is a distribution of record contribution to the table space. So basically it shows how many blocks are, how many records are smaller than this. And you can see that almost 100% are smaller than that. And you can see that the records with a smaller size, for this size, have much bigger contribution. So this area correspond to this, which is, you see there's no records here. This is small, the big hump and the small hump. So the contribution of the records of big hump is much bigger. So we basically will have all the almost all the records are up to here. That's why it's better to use, 32K instead of 16 in this case. Okay, well, I already showed this slide, so this is create a limit, and I believe I said that toss limit should be better. Creating toss limit appeared in version 10.1a. And let's see what we do with create and toss limit. This slide shows you the, I have 5 minutes, how you can see the create limit and toss limit. You can use it per area. And actually, all of these statements could be abbreviated. Whatever I have here in square brackets could be dropped. So you can run this per area and you receive a list. If you run this for the area that only indexes, you will receive, there's no objects in this area. But of course, much better to use VST for those. And you can set the create limit and toss limit for the table using these statements. And also you can use per area as well, but I don't advise you to do that. Okay, so toss limit. What kind of the toss limit you would choose for this table? And I don't know. Obviously, this looks like a lob. It's very difficult to choose toss limit for this table. Now, create limit. If the table is never updated, if you look at the table and the update statistic tells you 0, then create limit could be set to the 32, to the minimum, because you're not updating them anyway. However, if table is updated, then you need to look and maybe increase create limit for this table. And that is talk about this parameter. The value is basically, the default is 5, and this is how it is calculated. So basically, 5 multiply the data cluster size, which is like 512, for example. So like for the area that has 512, 5 divided by 10 is half of 512, so it's 256 plus 3, 259. So maximum of 259 blocks will be moved from front to the back. Changing this parameter, that's a recommendation from Progress. Because this parameter works one for all tables, that's why changing it does make sense. The value that works for one table may not work for another table. And this is screen from activity monitoring, which I showed you before, ActSpace, which is one for the whole database. And this is also good screen for Act Record, but again, it shows you how many creates, delete, and fragments. It shows information about fragments, but again, it's one for the database, not per table. And finally, the conclusion of presentation is basically that fragmentation is bad. You probably know this before you came to this.
Yeah.
Forget blue ball.
But a long RM chain, it's not very clear. RM chain serves its purpose of reusing the space, but longer RM chain, they lead to the fact that we can have a huge number of blocks, of empty blocks in the head of the chain waiting yours to be used. So this is kind of waste of space. And now if you have any questions. I have 3 minutes left.
Do we have one RM chain for the entire database, or do we have an RM?
In version 8, it used to be one RM chain for the whole database, but now it is per table. Except the type 1, of course. Yeah. So I'm talking about type 2 areas. I couldn't think about type 1.
Nobody should use type 1.
About those locks, when you said that if the records are fragmented,
Yes.
then locking occurs during the read.
Yes.
Due to station, the record is split into different blocks. Due to consistency, to get that consistency, are those locks observable from the lock table also? Those are normal, absolutely normal locks?
This is not the same logs as you have exclusive and shared logs.
Something, but also occurs, are registered in lock
Table.
table.
Yes.
Yes.
Okay. So the next situation, when we have the for each query, for example, and getting also values, log values. So means also when you that query runs on table with logs, then for that consistency also logs will be initiated or no. Something similar to when you have that is from consistency relates to two areas. Now not to different logs, but to two areas. So also the log also occurs or not. Getting one field, for example, character or integer, another one is
Lob.
so will that log occur to reach that consistency or not?
I believe lob is like any other field. So basically,
This is not the same log. Never will be
Yeah.
the same log, and very similar to that situation. For me, looks like similar to the situation that we have some.
Well, it's not the same because when you read the record, you don't read the LOB
You need to.
unless you ask for it.
Paul, do you need this?
No, that's it.
So will be no log.
Well, so when you read the record, it's got a LOB location field in it,
Yes.
which points to where the LOB is actually stored. So you only read the record and not the LOB.
But I'm talking about it very when I'm getting log in the same field list. I
Yeah.
have the also log field.
Oh, I'm sorry, I didn't understand that you're using field lists. Are you?
So if you read the record and the LOB at the same
Yes.
time, the
Yes.
question is, do you have the
The
record
question
get
is
logs?
when I'm reading at the same time, the same for each, for each customer, where you have customer name and customer photo, for example. The same fields,
Oh,
customer
okay,
name,
okay.
customer photo.
Okay, so it's still two separate
Yes.
operations. First you get the record, then you go get the LOB.
But
Oh,
to
we
be
got
getting
record.
that log, will I have that log, some kind of log? Or
Record.
not? Similar
Record
to
get
that,
log.
log we have.
Yes.
we have-
You have to have consistent read of the LOB also if it's fragmented.
So you would have record get logs. for
Yes.
the LOB.
Right.
So the question was for the lobs, will the lob has also record get logs? Yes, because the lob is like any other record, pretty much. If you have any questions, first of all, you can use by email, and the presentation has a lot of comments inside, which some of them I mentioned and some of them I probably skipped. So you can look through later if you need. Yes, one more question.
Are the create limits also applied when doing binary load?
No, a binary. No, when you do dump and load, then well, create limit, yes, but when you create the record are never fragmented when it's created. I'm not sure I mentioned it in the presentation. So when the progress creates a record, it's never fragmented.
Unless it has to be, right.
Unless it has to be, yeah. Unless it's like this big, it doesn't fit in a block. Like if you create records of that size, it doesn't fit in a block, it will be fragmented. But when progress creates, it creates a record the way it is not fragmented. It's only after updates it becomes fragmented. That's why the sports database doesn't have any fragmentation. Remember I showed the sports database with a customer record which could have fragmentation because of the trigger. In reality, sports database is not fragmented at all because it is dumped and loaded. Okay, thank you very much. Thank you.